Alright, today we will be talking about Maths 201 and we will be looking at a very familiar topic known as the gradient in partial differentiation. The gradient in partial differentiation. And so we said the gradient of a scalar valued function is a vector that contains all its partial derivative. Is a vector that contains all its partial derivative, and it is denoted by this. It is denoted by this, the symbol. And so you said that if to find the gradient of a function containing two independent variable system, df dx, df dy. If it's a three independent variable system, df dx, df dy, df dz. And so quickly we will be looking at some very important questions on this. How do we find gradients? How do we find gradients? Okay, example 1 said if f is equal to x squared y plus sine xy plus e to the power of x y. It said find the gradient. Find the gradient at pi and 1/2. This is a very important question, and I would like for you to pay full attention. To this question. So what is simply written on the board is a function that contains two independent variables, x and y. As you can see that here, x and y, right, was given to you, and you were asked to find the gradient at the point pi and 1/2. So what are the steps involved? What do we do from here, right? So first thing first, because there are two independent variables, x and y, so I'm going to find f of x, and what will be f of x. So what do? Partial differentiation enables you to differentiate a function while keeping the other as constant. Now we are paying respect to x, and so you cover y. And so when you cover y, you're going to be having x squared. You isolate x squared, right? Now if you differentiate x squared, you're going to be having 2x, and then you multiply it by the variable that is left, which is y, plus. Now how do we differentiate sine xy? Okay, how do we differentiate sine xy? What do we do? Now, because we are differentiating with respect to x, the variable that is not needed, which is y, comes out. And so we say y. Now let's differentiate sine. You know that if you differentiate a sine function, you will be having a cos function. And so you say cos, and then you repeat what is there before, x, y. Okay, let me break this down in case you do not understand what I did. Example, we have w equals sine of x, y, right? And then we said that let xy equals p, right? Now that we have said xy equals p, let's say w is equal to sine p. I usually do this in many of my videos so that you can have a full knowledge of what I'm doing. Now we say w is equal to sine p. What is the next thing for us to do? Let us do the w, the p. And so the w, the p is cos p, right? Now that we have the w, the p to be cos p, let's say that, remember that xy is equal to p. So let us do the p dx. Why am I doing the p dx? Because remember, I am differentiating this function with respect to x. I am differentiating this function with respect to x. So it will make sense for me to do a chain rule that says the w, the p, should multiply the p dx, so that I can then cancel out and have the w dx. Is that correct? So the p dx is y. The p dx is y. And so now that I have the p dx to be y, then I can say the w the p, which is this, the w the p, which is cos p, should multiply the p dx. And what is the p dx? The p dx is y. That is why you have it like this. So you're going to be having y cos. Now remember that p was xy. Remember that p was xy. So this is what you're going to be having. So y cos xy. Y cos xy. And so to make things easy, I said when you want to differentiate this particular function with respect to x, all you need to do is to remove or take away that function you're not differentiating, bring it outside, and then differentiate this function. And so when you differentiate this function, you have a cos, then repeat what is there before, xy. Okay, so I haven't said all of those. Let's continue. How do we differentiate an exponential to the power of xy? An exponential to the power of xy, we said bring the function you are not differentiating, y, bring it out. And so when you bring that out, you'll be having y, right? Then repeat what you have upstairs, xy. So having said that, let us do f of y. Remember, there are two independent variables present in the system. We have x and we have y. Now that we have done f of x, let us find out what f of y is. Okay, the same thing here goes here. Now this time around, because we are paying respect to y, we are differentiating only y. And so if you differentiate y, you have 1 multiplied by x squared, you have x squared. You have x squared plus, again, you're differentiating this function, sine of xy. And so when you differentiate this function, what you do here, just reverse the role. So because here is y, this time around, here will be x cos xy plus, again, reverse the role. This will be x e xy. Yeah, so now that we have been able to do that, what can we say? The next thing for us to do is to insert the point. This is step one. Now we have step 2, inserting the points. Let us insert the point. It means that f of x will be 2 into the bracket. Now, these are the points given, pi and 1/2. And so we said that this should represent x, this should represent y, right? So we have pi, and then we have 1/2, then plus, we have 1/2, then we have a cos function, then we have a pi multiplied by 1/2, then we have plus, right? We have a plus, and then we have 1/2, an exponential function e raised to the power of 1/2 times pi. Did you see that? Very easy, right? We are inserting the points. And so we have f of y f of y. What will be f of y? F of y will be x. X and x is pi. So we have pi all squared plus pi cos pi times 1 over 2 plus pi exponential pi times 1 over 2. That is f of y. And so, having said that, we were able to discover that f of x is so this is 2 cancelling 2, so this pi times 1, that's pi, right? F of x is pi plus, now what can you say about this? What can you say about that? So we have pi multiplied 1 over 2 multiplied by cos into the bracket of pi times 1 over 2. What do we have there? Simply put, that we have 1 over 2 cos. Did you see that? 1 over 2 cos pi. Did you see that? 1 over 2 cos pi, right? So our f of x is 1 over 2 cos pi, right? Because we have y to be 1 over 2. This is y to be 1 over 2. We have cos, right? And we have pi xy, right? We have xy and x is pi, and then we have y to be 1 over 2. Y to be 1 over 2. So we are also multiplying this by 1 over 2. Multiply by 1 over 2. Multiply by 1 over 2. Let me just cover this, right? And then we have plus, right? Plus y again is 1 over 2. 1 over 2. Then we have exponential to the power of 1 over 2 pi. So f of x will be equal to pi plus 1 over 2 cos pi over 2. Did you see that? 1 over 2 cos pi over 2 plus, did you see that? 1 over 2 e to the power of 1 over 2 pi. So that is f of x. That is f of x. Now let's look at f of y. F of y. Let's look at f of y. So f of y will be pi squared plus pi cos pi over 2 plus pi e to the power of pi over 2. That is f of x, and that is f of y. F of x and f of y. Having said all of this, then we can see that the gradients of the function and what is the function? The function f equals x squared y plus sine xy plus e to the power of xy is, the gradient is f of x comma f of y, and we have it as pi plus 1 over 2 cos pi over 2 plus 1 over 2 e to the power of 1 over 2 pi comma, pi squared plus pi cos pi over 2 plus pi e to the power of pi over 2. Did you see that? So that is the gradient of the function. That is the gradient of the function. Now let's look at something more interesting. Let's look at another example on gradients. Let's look at another more interesting examples on gradients. Gradients. It says determine the gradient. Determine the gradient of the function. Determine the gradient of the function, a function containing 3 independent variables, which is equal to x squared plus y squared plus z squared minus 3xy minus 2xz minus yz. Did you see that? Let us determine the gradient of the function. The gradient of the function. Okay, so we have f of x. We're differentiating with respect to f of x, f of y, f of z. These are the steps. These are the steps taken. These are the steps involved, or you can say the steps taken. Now, why am I differentiating with respect to x, with respect to y, and with respect to z? Because we have 3 independent variable system. You have x, you have y, you have z. Right? We are finding the gradient of this function at, look at it here, at 1, 2, minus 1 gradient. So let's do that quickly. What will be f of x? Remember, when we differentiate x squared, you have 2x. Okay, now 2x. Let's go to the next person. Is there x here? No. So this becomes 0 automatically. Is there x here? No. This becomes 0 automatically. And then we have minus 3xy. And so if you differentiate minus 3xy, you have minus 3y. Minus 3y. Minus 3y. Because if you differentiate x here, you have 1. 1 multiplied by 3y, 3y. Alright? The next is minus 2xz. Minus 2xz. How do we differentiate that function? Again, because we are differentiating with respect to x. X here is 1. Differentiate x, you have 1. 1 multiplied by 2z, we have 2z. So minus 2z. Is there x here? No. So that's 0. That's 0. So let's go to y. F of y. What will be f of y? Is there y here? No. 0. Is there y here? Yes. Let's differentiate with respect to y. You have 2y. Is there y here? Yes. So if you differentiate here with respect to y, you have 1. 1 multiplied by minus 3x, you have minus 3x. Right? Is there y here? No. Minus 2xz. There is no y in that constituent. So we take it out. 0. And then you have minus yz. If you differentiate with respect to y there, you have z. Then we go to f of z. Again, because we are differentiating 3 independent variable system x, y, and z. Now f of z, is there z here? No. Is there z here? No. Is there z here? Yes. So we have 2z minus, is there z here? No. Is there z here? Yes. Minus 2x. Minus 2x. Is there z here? Yes. Minus y. Why is it minus y? Because if you differentiate this function with respect to z, you have z as 1. 1 multiplied by minus y, you have minus y. Okay, so now let us insert the point. Insert the point, that's step 2. Insert the point. And so if you insert the point, f of x will be 2 into bracket 1 minus 3 into bracket 2 minus 2 into bracket minus 1. F of y will be 2 into bracket 2 minus 3 into bracket 1 minus 1. And f of z will be 2 into bracket minus 1 minus 2 into bracket 1 minus 2. Did you see that? So we are simply placing the points x, y, and z. Let's not forget this person represents x, this person represents y, this person represents z. X, y, and z. And so we find out that at the end of the day, f of x is minus 2. F of y is 2. And f of z is minus 6. You can try that here. 2 times 1, 2. 2 minus 6. 2 minus 6 is minus 4. Minus 4 plus 2. Minus 4 plus 2 is minus 2. So this is minus 2. Okay. What about this? This is 4. 2 times 2, 4. 4 minus 3 is 1. 1 plus 1, because minus multiplied by minus is plus. So 1 plus 1 is 2. So we have it as 2. And then you have it at minus 6. Alright? This is 2 times minus 1 minus 2. Minus 2 minus 2 minus 4. Minus 4 minus 2 minus 6. Is that correct? So we have it like this. Minus 2, 2, and minus 6. And so because of this, we say the gradient will be minus 2, comma 2, comma 6. If you want to put it in vector form, in scalars, you want to make it look nice, you can say that the gradient of the function is minus 2i plus 2j minus 6k. You can put it like this. So this is the solution to finding gradient. This is the solution to finding gradient. All right.